Input voltage, output voltage, pulse voltage.
What is this?
Pulse voltage, sir.
Pulse voltage. Okay, firing pulse.
Yes, the firing pulse, gate pulse.
So I told you, let's show your observation table. Then I'm asking. Okay. Huh.
Yes, sir. Yes. Load current. Now RLE load. Input voltage, output voltage, load current, and then RLE with freewheeling. Output and load current. And now observation tables in the portrait mode.
Okay, zoom out, karo, please. Please make them zoom out.
Okay.
Okay, it's coming. Okay. Huh.
Yes.
Achha, so your first is that you are varying resistance.
Yes, sir. Resistance for RL load.
So for RL load, achha, only 3 samples are there.
No, sir. 10 samples. 10.
10 samples. Good. Achha,
Yes,
that voltage waveform is okay. Scroll up.
Yes, sir.
You didn't include current waveform?
No, sir. I have included the voltage or output waveforms for all the variations.
Okay, so actually current waveform also important for this control rectifier. Why? You can see, okay, so the critical conditions, mean continuous conduction to how it is coming to discontinuous conduction. That is another important study. Okay.
Yes, sir.
Okay, so here you are varying the resistance. Okay.
Yes, sir.
But in control rectifier, that parameters is okay. But another important features is here changing variations of your firing angle. Okay. That study, do you, which parameters you have taken? Let's show me the title of that column.
Yes, sir.
Input current. Okay. Input current, resistance value, input current, power input. Okay.
Yes,
just for a moment. Then load voltage, load current, power output, efficiency. Acha, that error you didn't calculate, that error, voltage error.
No, sir, I didn't calculate. I will include it.
I include this table. Okay, this column. Okay.
Yes.
Another thing, just for curiosity, that if why efficiency is so less, can you please enlighten that portions? Why the efficiency are less?
Yes, sir. First of all, we are using half wave rectifier. Usually in the diode, we are getting around 41, 42%. But using this RL load and the thyristor, we are getting improved efficiency of around 50%. But if we are using bridge wave or a full wave rectifier, then we can get around 70, 80 or 90 percentage of conversion efficiency.
Okay, how do you increase the efficiency level?
We can use the freewheeling diode. We can tune using L and R values.
Good. So that column you please add. Okay.
Yes, sir.
Do you plot this one?
Sir?
Plotting that Excel file I told you, plotting Excel graph.
No, sir. But before submission, I will be plotting it, sir.
Okay. Plot it. Okay.
Yes, sir.
So plotting, in the case of plotting, what you need to do, that x-axis is your load resistance. Okay.
Yes, sir.
X-axis is your load resistance, so y-axis is your current, voltage. Okay, output voltage, output current, and efficiency. Okay, that you can do. And another study you need to do for R load, RL load, and RLE load. Okay, that you are telling about that by using freewheeling diode, the efficiency may be increased. Did you see that portion? When in that observation table, do you study from that point? Do you study that one?
No, sir. I didn't kept any variations for freewheeling diode. I didn't study, but I have only done simulation.
Okay, you please cross check it. Whatever you are telling, so better you put an observation table. Okay, so better you put an observation table, so we can also see that how the efficiency changes. Exactly same resistance value. Okay, Or if you using RL load you are using, so exactly same in RL load we are varying the inductor only. Okay, so exactly same inductor value we'll see. Okay, so how the efficiency are changing. Are you getting my point?
Yes, sir, getting, sir.
How it is improved. Okay, how is it improved? Okay, so that is an important issue, and that current waveform you need to incorporate. Another thing, that changing of the firing angle. Okay, firing pulse, that yesterday last class I told you that you can start 0° means exactly same like your diode rectifier. Okay, so you can also start from 0 for your better understanding, or you can start from 30°. So 0, 30, 60, 90, 120, 150, 180. Okay,
Yes,
that sample you take for results for R load, RL load, and RLE load. Okay, and if possible with that freewheeling diode based operation. Okay,
yes, sir.
so we can see how the currents waveforms are changing. That is very important. Okay, voltage is there. Voltage also you have to fetch as well as the current waveform. Is it coming from continuous conduction to discontinuous conduction mode? What is your boundary zone? That study is required. Okay,
Yes.
and that column you have added. So another thing is that calculated. Okay, that means calculated output voltage. Okay, that from the formula you directly put that value. Okay, you have that all the parameter, maximum voltage, firing angle. So you can calculate the output voltage, average output voltage, and you can measure it. Okay, so error column you please add. Okay,
yes, sir. Okay, sir.
Okay, so okay, please scroll down it.
Yes, sir. This L variation.
What is this? This is acha, scroll up karo, please scroll up it.
Yes, sir.
What is the title of this table?
Table for RL load converter with the constant R and the gain and the change in L.
Acha, that voltage waveform, why it is changing? Scroll down karo, thoda distorted. It is showing like a distorted one. That sample number. Scroll down it.
Yes, sir.
Acha, this one is 4. Okay, 4 is okay. Just hold a minute. I got an important phone call. Just.
Yes.
Okay, sorry for that interruption. Okay, let's just scroll down it.
Yes.
Acha, sample 5. Okay, now waveform is quite distorted for very less value of inductor. Okay, so if you see the current waveform, you can also see how much voltage amplitude. Amplitude is how much voltage amplitude? Load current, load voltage. Acha, that means fourth column. Okay, fourth column.
Yes, sir. This one 25.1.
Current amplitude also very less.
Yes, sir.
Okay, so input voltage is not given. Okay, RMS input voltage you please add.
Yes, that is standard, no, sir. So I kept 100 in that.
Acha, RMS, na. So after giving 100 volt RMS, so load voltage is coming very less.
Yes, sir. First we got 98, 94, and then it decreased.
Then gradually decreasing with increasing of the inductor value.
Yes, sir.
And current value also decreasing.
Yes, sir.
Scroll down it. Now it is more or less 0, nearer to the 0. Current is 0.0123 ampere. Na? So after, if you vary more, so it can be go up to discontinuous mode. Okay.
Yes, sir. Yes, sir.
Current waveform you please add. So you can see. And that alpha. Okay, so alpha you are varying from. In that case, you can see the alpha variations are just like a you know that alpha variations, how to calculate the alpha? That's the point. Okay, suppose you know that we are considering 180, na? 180 up to 180 degree. So we are using that if you generate the alpha, how to get the value of alpha? Okay, so just a moment. So alpha value, how to get it? So 180 degree means pi. Okay, pi radian. Okay.
Yes, sir.
So 180 degree means pi radian. Okay. So by that way you can get it. So how did that value? So 180 degree means you know that 10 millisecond or 20 millisecond. You please cross check it. It's a 50 hertz. Okay. So it's
Yes,
your
sir.
50 hertz signal. So if you considering for first cycle, so it is nearer to the 10 millisecond. Am I right? So
Yes, sir. Yes, sir.
20 millisecond is for
20
50
millisecond.
hertz, but
Yes, sir.
you are taking if one cycle, so it will be 10 millisecond. So 10 millisecond nearer to the how much value? Okay, that you have to calculate. Okay, so by this way you can find out the angle. Okay, so that when you are changing the firing pulse, okay, so you just given the degree. Okay, degree value means
Yes,
you have to scale when you calculate the time range. Okay, suppose 10 milliseconds maybe nearer to the 180. Okay, like that. So you cross check it, whatever I am telling you, cross check it and give that only degree value. Okay, so
yes,
you have to convert this one. ठीक है?
yes, sir. Yes, sir.
Scroll down करो.
Now RLE load, sir.
RLE load.
Yes, sir. First I have used R. Variation in R.
Variation of R. Okay.
Yes, sir. And then variation of L. And then the variation of E, sir. Back
V.
EMF.
Okay.
Yes, sir. Alpha I didn't do, sir. I would be doing.
You do that alpha, then
Yes, sir.
that corrections, modifications I've suggested, you complete
Yes,
it,
sir.
submit.
Yes, sir. Yes, sir.
Okay. Okay,
Yes.
thank you. And conclusion question, please add. And conclusion
Yes,
that chart, sorry, that Excel figure.
Excel sheet,
Okay.
yeah.
Excel
Yes.
sheet figure. Okay, so
Yes, sir.
individually, so voltage, current. Okay, for changing of the alpha will be in x-axis. How much voltage, current, individual diagram you provide. Okay.
Yes, sir.
And theory portions may be enriched. Okay.
Yes, sir.
Okay. Okay. Thank you, Sai. Mahesh. Mahesh.
Yes, sir. Yes, sir.
Acha, what about your last experiment report? I didn't get that link actually, the submission link.
Okay, sir.
That
I
Google
will
Drive.
send-
Okay. You please share me that Google Drive link. Okay. So after completions of the students submission, okay, you send it to me. Okay.
Okay, sir. I'll send you in the mail.
In mail, WhatsApp, or whatever. Better you send it to mail. Okay.
Okay, sir.
So I keep it. I just collect the link. Okay. So later again I will talk to you for that final submissions. That time I also discussing with you. So
Okay.
what they need to do, then come clubbing all the files. Okay, that also required at the time of final submission.
Okay, sir.
Individual submission first. Right now I'll take the individual submission. Okay. So
Okay.
then final. So keep it with you and send it to me. Okay.
Okay, sir.
Okay. So next one is a Monorama Kumari, roll number 307. Monorama, am I audible?
Yes, sir. Yes, sir.
Can you please share your
Yes, sir.
Can you please share your simulation?
Yes, sir. Yes, I'm sharing. Sir, is it visible?
Yes, it is visible. Halfway thyristor rectifier. अच्छा and scroll down करो. Theory. अच्छा.
For different types of load, I have shown the graph and circuit and explained the theory.
That mathematical calculation
Yes.
for
Then
performance
parameters.
Okay.
The formulas and then the procedure. And I started with the single phase half wave using R load.
This is for R load.
Yes, sir. This is like varying the alpha.
Acha, varying the alpha. So
Yes, sir.
in degree, na? Acha, how to calculate the value?
So using the phase converter, like I use
Okay,
that.
okay. Directly, there is another option. Mane, directly that angle you can also give. Am I right?
Yes, sir. Yes, sir.
Okay, okay. So by that way you can also do. Yes, go to 0 degree means direct. Okay. Acha, only how much variation? 5 variation.
No, yes, yes. In this, I have done only 5 variations.
Only 5 variation. Is it sufficient to plot the graph? So better you do it. What you can do to make it
Yes,
up to make it up to 180 degree. That how much sample you have
yes.
taken? 0,
Yeah,
0,
110 till 110 I have done. I can do it till 180.
120, 150, 180. Okay. Let's see. And the waveform, what kind of changes do you observe? So scroll up karo. The current waveform you didn't include? Current waveform?
Sir, I have only included the current waveform for that alpha is equal to 0 degree only. Like in this, I have only done for voltage waveform. I have not done for this
Current also
current waveform.
important. Okay. Current also important.
Yes, sir. I am thinking to include all this like voltage and current
Voltage
variation.
calculations, error that you have now also given.
I have calculated this efficiency. Error is not I have calculated.
So error is also required. So how much accurate your calculations? Okay.
Yes, sir. Yes.
Voltage
I will
output
include
is
that.
there, RMS. Okay. So error you have to include, and the current waveform you need to include. Okay. Acha.
Yes,
Plotting.
yes.
Did you include the plot?
Yes, sir. Like for 0 degree, I included the plot for each
Plotting
graph.
means
Like
Excel,
for
Excel file plot curve.
Excel files, sir. Actually, I didn't get the time. I am on the train. I was on the train, so like I didn't get the time for doing that.
Okay, okay.
I
So
was
complete it. Okay.
Yeah, I will definitely include that Excel file one. Then I did for RL load. This is for alpha 0 degree only, and then for variation, here I have included the input voltage and load current waveform for changing the value of L.
Acha, changing the value of input voltage, load current. Okay. Acha, other parameters.
Yes, sir. Like here, like I have shown changing the value of R, the voltage waveform variation. 10 values. Here's only 8 values I have taken. I was taking the 10 values, but I didn't take it. Yeah. That was for alpha is equal to 60 degree only. And then this RA load with freewheeling diode. here I have started with changing the value of R.
Okay.
Sorry. Here. And in this, I had to include with the changing the value of L. Sir, I have not included that.
That you have to include firing angle variation.
Yes, sir. That L value and alpha value, I will just include that.
Okay, so that
See,
also
I have
required.
only changed here the R value.
Okay, so you please revise it. How means what you need to include that I have already discussed. Okay.
Okay, sir.
So that portion you please include it so it will be completed. Okay.
Yes,
And
sir.
submit the revised versions. Okay.
Okay,
Good.
sir. Thank you.
Good. Smoothie Sika Panigrahi. Am I audible?
Yes, sir.
Can you please share your simulation?
Yes, sir.
No, till now it is not visible. Please reshare it.
Yes, sir.
No, it is not visible. You please rejoin it and reshare it. Okay.
Okay, sir.
Smriti Shekhar, can you please share your work? Yes, your screen is coming, I think so. You may share your simulation. Yes.
I've done in MATLAB.
Okay, you have done in MATLAB, not Multisim.
I'm using MacBook and their multisim can be installed, so that could be.
Okay. Acha, so in MATLAB, okay, scroll down karo. This is your report. Is it your report?
Yes, sir.
Okay. When you are using MATLAB, just wait a moment. So what you need to do, that black color of diagram you cannot incorporate here. So what you need to do, that waveform is there, so you can enable the scope data. Okay, so that scope is there. Okay, you please enable the scope data inside of the scope. Okay, so when you are enabling the scope data, so just there is some 1 or 2 line code is there. Okay, you cross check in Google. Okay, so what you can do, you can plot the scope data. Okay, plot the scope data means that waveforms, whatever you are showing here, that you can directly plot it from the workspace. Okay, so in the MATLAB. Okay, if you are able to plot it, so that color may be changed. Okay, so black color, it's not like the black color. So you can see the blue color waveform. So you can increase the thickness of that waveform. Okay, color waveforms and all those things. Okay, you can change it. So based on that changes, okay, based on the changes, directly you can also you can include the axis name over there. Okay, your axis name are not there in this diagram. Okay, you can change it. Axis name, time, and a time x-axis your time is required, y-axis voltage, current. Okay, input voltage, output voltage, current. Three things are there. I am observing, but name also required. You are getting my point? Are you getting my point?
Yes, sir.
Please modify it. Black color diagram is not expected. Nobody cannot understand from the diagram. Okay. Scroll down karo. Okay, but that observation table, acha, show me your observation table.
Sir, yeah, MATLAB, it is difficult to get single values in the waveform like in MATLAB.
Okay, now actually you have to include the observation table. Okay, so observe. I think you can see that your friends are showing how they are showing the observation table. Okay, that you need to incorporate. Okay, so observation table is very important. Okay, so please please include it. Okay, observation table. Observation table with the changes of waveform, that also important. So all those things are very important. So please incorporate it. Okay, so it's needed. Otherwise, we cannot understand in proper manner how it is working. Okay, so it's very important. Okay, you are getting my You are getting my point? Are you getting my point?
Yes,
Yes.
sir.
Okay. Please update it. Okay.
Okay, sir, I will update and send.
Okay. Update it and resubmit. Okay, thank you. Hey, Jafar, 294, Muhammad Jafar Khan.
Yes, sir.
Please share your simulation.
Yes, sir. Actually, I got some issue in laptop. I'll share like in just 5 minutes. I rejoined with my mobile. Just give me 5 minutes, sir.
Okay, please be ready. I'm going to next student. Then again, I am coming. Okay.
Okay, sir. Okay, sir.
The next one is Harendra Kumar. Roll number 302. Harendra Kumar. Absent. Harendra Kumar. Am I audible, Harendra? Okay. He may be absent. Okay. I'm making him absent. Mehul Kumar. Mehul Kumar.
Yes, sir.
Please share your simulation.
Yes, sir.
First share your simulation, then write up.
So is it visible?
No, nothing has come. Nothing
Now?
has come. No.
So I have reshared.
You have reshared, but nothing is coming here.
I'll rejoin. Then I'll share.
Okay, you
Don't know
rejoin
what's
it and
happening.
again share. Okay, good. And Niranjan Kumar? Niranjan Kumar? Absent. Niranjan Kumar? Those are giving attendance, then not responding. I'll cut their attendance twice actually. Okay. Niranjan Kumar? Okay, I'm just cutting his attendance. I'm marking them. Those are not responding. I'm just marking them. Swati Malik.
Yes, sir.
Please share your simulation, then report.
Yes, sir. So is it visible?
Yes, it is visible. So make it. Okay.
So this
Scroll down.
is what?
Yes. Acha, simulation. Swati, simulation.
Yes, sir, I have to open it.
Open karo, no problem. Open the simulation file and run it.
So is it visible?
Yes, it is visible. Okay, make the waveform in full screen. Okay, yes. Please discuss this. Okay, please discuss your waveforms.
So this is the input voltage waveform, and then this is the output voltage waveform.
Acha, your fire, acha, it is firing pulse is not there. Am I right?
Yes, sir.
0 degree firing pulse.
Yes, sir.
Acha, so it's your control rectifier, na? So make some take some show some results with having some firing pulse, a 30 degree firing pulse. Can you able to show it now?
Sir, I used the phase converter for that thing.
So give that angle.
So that circuit I have not saved.
I'm not getting what happened.
Sir, I have used that phase converter for changing the firing angle, but that circuit I have not saved now.
Okay. But okay, whatever you have, please show me now. Then you can update it in that report. Okay.
This is a simulation for the RL. Then this one is for the RLE, and this one is for R, and this one is for RL with the free wheeling diode.
Okay, good.
And this one is my report.
Report. Acha, scroll down karo. Acha, you need to. Okay, in your report, I just observe that is left aligned. Okay, so make it in justified manner. And theory portion is very less. Okay, in theory, what you need to write, brief write up about your circuit, individual loading conditions, circuit and their waveforms and their calculations. Okay, mathematical calculations for getting that average voltage, current, calculations. Okay, for R load, RL load, RLE load. Okay, if freewheeling diode is there, so what will be their equations? Okay, that you need to incorporate. Okay, go to your observation table.
This is for the R load. with the variation of the firing angle.
Acha, with the variation of the firing angle, okay. Did you change that resistance value? How is it coming? Did you see?
For the RL load, I have changed the R and seen these
Acha, you please
observations.
incorporate the current waveform also. Okay, voltage waveform is okay. Current waveform, if you are able to incorporate, so we can understand that how the is changing. Okay, how it is changing, so we can understand better. You're getting my point?
Yes, sir.
Good.
And this is a variation of alpha for the RL load.
Okay.
And for RLE load, I have not completed the observation table. Only I have done for single values.
Acha. Did you prepare that that Excel graph?
No, sir, I haven't prepared that.
Okay, you please prepare it. Okay, you please include it.
Yes, sir.
So we can learn better. Okay, so how it is changing, so we can visualize the changes. Okay, that's very important. So at the time of final viva, I will ask all those points. So if we changes all those things, how your efficiency is not coming good, how it is changing. Okay, you have to defend that one. So how do you defend it? So definitely, if you are not realize the problem, so you are not able to defend yourself. So that's why the problem realization is very important. Okay, that's the motivation for doing the lab. Okay, so otherwise the things are very simple. Okay, so your observation table and the idea you are getting from your observation table, that's the prime and thrust point of this simulation lab. Okay, so all of you are trying to do that one. That's a very good sign. Okay, good work, Swati. Thank you. You please update it. Okay, update it and
Yes, sir.
resubmit it.
Yes, sir. Yes, sir. Thank you, sir.
Thank you. Again, I am asking the previous person. Okay. Hey, yeah, Muhammad Jafar Khan, Jafar.
Yes, sir. Yes, sir. Sharing, sir. One
हाँ,
second.
share करो तुम्हारा simulation first.
Yes, sir. Hello, sir. Can you hear me?
हाँ, you are properly audible. Please share it.
Yes, sir. Just a second. Yes, sir.
Yes, it is coming. Actually, simulation. First, show me your simulation.
Yes, sir. Actually, this part, I didn't document it correctly because I was doing in two different things. I made a RLE load in this manner, one side, and this one is the main document which I didn't complete yet. I didn't document the whole thing correctly. I just did the whole simulation.
Acha, okay, but you have. I hope you have the simulation file. Can you please run your simulation file?
Yes, sir. 1 second. I think I deleted it. Maybe. Yes, sir. I deleted it most probably because I took the
Simulation file
simulation.
deleted. I'm not convinced with your answer. Simulation
I
file
mean, sir,
deleted.
like I didn't save it that time at that point of time.
Please, that first class I told you. Okay, please be ethical. Okay, so I'm not trying to say anything. I know I can understand that what I mean to say. I hope you are able to understand. So simulation file is very required. So next class.
Yeah,
Okay,
sure, sir.
again
Sure,
I am
sir.
asking for the simulation file. Okay, so
Yeah. Okay,
try
sir.
to do it by yourself. That's the.
No, sir, I did it,
We are
but I
not
didn't
maintaining
save it. I
the.
like took whole photos and
Well,
that time I
it's
didn't.
not feasible. Those are doing the simulation and they didn't save the simulation. It's not.
Okay,
This
sir.
answer
Like
is not
I'm
convincing. Okay.
Okay, sir, I'll save it. I'll save it.
That report anybody can show it. Okay, so that's good, no problem. Okay, so
Yes, sir.
okay, so do your work by yourself. Otherwise, what happened? That
Yes,
kind
sir.
of impression. Actually, I know all of you. Okay, so last 4 years I am always regularly touch with you. No, so I know all of
Yes,
you. Okay, very well. You all also know that that I
yes,
know
sir.
all of you very well. Okay,
Yes, sir.
so so try to. That's why I'm asking you, and then another 3 students again. I'm going to ask their name. Okay, so that's the
Okay, sir.
reason. So I'm trying to support you to encourage yourself. Means at least you should do something. So you should learn something from this work. Otherwise, the entire time is wasted. Na? So my target
Yes.
area is very simple. So most of the students should be benefited, especially those are all of you are very good, no problem. So most of the students should be benefited. That's why I have planned the lab in this manner. Na? Otherwise, what happened? I give some simulation. Okay, simple simulation. It's okay. Over. No problem.
Yes,
But
sir.
by this way, we are spending the time. But proper learning, you are not. We are not getting the way of proper learning. I mean, something you should learn from this lab. Okay, so that's
Yes,
why
sir.
I am telling like that way. Otherwise, why we are unnecessary now? So if I give lot of job unnecessary, you will do some of the students they are giving really they are giving their report. Okay,
Okay, sir.
in serious manner they're giving their report. Some of the students are not giving, so that is not correct. Okay, so please cooperate
Okay,
with
sir.
me and also try to learn something. Otherwise, time will be gone. Then you are almost final semester. Okay, after that,
Yes, sir.
next semester there is no one in next semester. No one is going to say like that. Hey, Jafar, please paro, ye karo, wo karo. No one is going
Yes,
to
sir.
tell you like that. Okay, so this is the last options, and you are almost verge of completion. Okay, please do the
Okay,
work
sir.
very okay serious manner. That's the point. Na? So that's why I'm telling you.
Yes.
Okay.
Yes.
Okay, good. Okay, so please next class again I am asking you show me your
Okay, sir.
simulations. Okay, whatever experiment I am going to share you. So you please
Okay.
do it and show me your simulation. All of you. Okay, I am asking only Jafar means it's not like that I am pointing Jafar. Okay, I am
Yes.
asking all of you. Please be ready with your simulation. Okay, so I can ask for simulation file then report. Okay, it's not like that you are exchanging your file with your friends. No, you can do it, but what happened? You are not able to learn it. Okay, that's why whatever you are giving your effort, please give your money. You should learn something. That's my point. You can also give. You know that Arnav sir is not like that. He is very. It's not like that. I am giving marks to anybody. It's not like that. I try to help my students. Okay, so how much I can give my sides as per the marks evaluation that I can give it to you. All of you know it very well, man. All of you know it. But problem is that if you are not support me, so I'm not getting a good feeling from the batch. No? So that
Yes, sir.
is not required. So that's why please cooperate with me. Means do your work by yourself. Okay, that's
Okay,
the
sir.
motivation. Okay, thank you. Next,
Thank
I am asking another students. Okay, Harinder Kumar. He's writing me that he's disconnected. And now you are audible, Harinder Kumar.
Yes, sir.
Can you please share your simulation?
Can I share in my mobile? My laptop is shut down.
Again, what you are telling? Laptop. What happened to your laptop?
Shut down, sir.
Shut down means you don't have the charger of the laptop.
No,
Again,
sir.
silly excuses you are given.
Sir,
Harinder,
at village
what
and my
you are thinking that definitely you may think that Arnav sir is do not understand my idea. You can think like that way, but you can also understand that not very few years back, I am also not few years back, almost 1 decade, 10 years back. Now it is 2022, no? Almost 10 years back, I am also the BTech student. Okay. So not 10 years, more than 10 years. Okay, 2010, I just got graduated. Okay, so that so you are giving the excuses, and I can also understand. I am not able to understand. It's not like that. Okay, next class I am also asking to you. Okay, that time laptop is shut down. it is not working, or that kinds of excuses I am not, it's not been considered. So I am marking all of you. Okay, so it's not like that. That's why I am asking your name. Okay. ঠিক আছে? Mehul Kumar.
Yes, sir.
Okay, so can you please share it?
Yes, sir.
Share your simulation.
Is it visible?
Your computer screen is properly visible.
Okay, sir. So here is the first circuit.
Good. You can also use the here. You can see that pulse generator you are using. Now go to your simulation file. Yes, that you can also change. There is some another another pulse generator. Okay, where you can directly give that angle. Okay, suppose 60 means 60 volt means 60 degree. 0 means 0 volt means 0 degree. So another pulse generator is there. You please check it in the library. I think you will get it. Okay, or the
Okay,
previous simulation I have shared, you can also get from there also. Okay, and some of the simulation I have that is use that pulse generator that you are using. If you go for future simulation, that type of thing is incorporated over there. Okay, so you can check that previous video so you can see how it is work. Okay, so you can change it. So directly changing the angle will be quite helpful to you. Okay, show me.
Okay, so this is the second circuit, RL load. This is the third one with the freewheeling diode RL load.
Please simulate the circuit. Show me the waveform.
Yes, sir. So these are the waveforms.
Okay, please discuss it.
Okay,
How much
so
firing angle you are using? How much firing angle?
it's a 0 degree.
0 degree. I show something and enable all the 0 degree. Make it. Some firing angle is there, no? Not 0
yes,
degree.
sir.
Yes, sir. Your simulation.
So this is the input voltage.
Then output voltage. Show me output voltage. What is this?
So this is the output voltage.
Acha.
This is the load current.
Zoom in karo. Zoom in the load current. How they are looking, I need to see. Acha.
So this is the report.
My name is not required. Submitted to Arnab Ghosh is not required. It's your report. Your name will be there. Okay.
Okay, sir.
My name is not required. Theory, you have written in left alignment. Okay, make it in justified. Okay. Theory.
Okay, sir.
Mathematical calculation.
Sir, I've added these graphs.
No, mathematical calculation also need to include. No? So how to calculate that average voltage?
Okay,
Otherwise,
sir,
the table you are using, okay, the table you are using where you need to calculate the V average. So how do you calculate it? So formula, you please write down the formulas. Okay, you can use the mat type. Okay, for the formula, you can use the mat type. You can download the software and directly incorporate it. Lower version you can download. So automatically it will be integrated your Word file. Okay, it is your Microsoft software directly integrated with your Word file. So where you can put your equations, or in Word file also there are some equation
yes, sir, yes, sir.
writer is there. You can use that one also. Okay.
Okay, sir, I'll do that in the final report.
Good. Revised report, you will do it.
Yes, sir. This is the simulation part for using R load. These are the waveforms. And sir, I haven't added the observation table because I was absent in the last class. I heard just now that we have to add, so I'll add that in the final report.
Please add it. Okay, that you know that I have discussed already how to add it, so you can also check the previous recorded version. So how you need to prepare. Okay.
Okay.
So all the resources are already available with you. Okay, please prepare your report as per the standard.
I'll do that
what other persons are given. Okay.
Yes, sir. I'll do that. Sure.
Good.
So this is with the RL load with freewheeling diode. These are the waveforms. And the last one is with the RLE with freewheeling diode.
Okay, so complete the observation table, then your conclusion also changes. Observation table and the plotting. Okay, in Excel file you have to plot it. Okay. So what columns need to add, everything I have discussed. Okay.
Yes, sir.
Okay, thank you. Any of you want to show your report or or your simulation? Any of you want to share your report now? Any of you are want to share your report to me? You're not interested to show your report? Okay, so I have shared your extra number 3. Okay, in WhatsApp as well as MS Team. Did you receive it? Sorry, do you receive it? Hello?
Yes, sir. Yes, sir.
Do you receive it?
Yes, sir. Sir, only on
In WhatsApp, I have also shared. Okay, please check it. So till now, what we have discussed with that uncontrolled and control for half wave. Okay, So now what we need to do, we are clubbing that report is consist of that experiment number 3 is what? Analysis of single phase full wave diode. Okay, means uncontrolled. Okay, and thyristor within bracket controlled, rectified using different load. So same study now we will do for uncontrolled and controlled for the same study. Okay, for the same experiment. Okay, with full wave configurations. Okay, previously it was half wave. Now we are doing for the full wave. Huh. So, so here we are going to discuss that. Previously, we are discussing about that half wave diode. Now we are discussing about the full wave. Okay. So here we can observe that you know that objective of that simulations same. Okay, R load, RL load. Okay, RL load with freewheeling diode, RLE load, and RLE load with freewheeling diode. So theory portions very briefly it is written over there. Okay, so full wave converter. Okay, midpoint converter, how it is given. So some of the idea is given, but you can give it quite elaborate manner, means you are also giving brief manner. Okay, also mathematical calculations or formulas. Okay, so formula you can write in your Word file. Okay, so directly here we are using that cropping that equation and give it to them. You can write it over there. Okay, so procedure, you know that portion is common. Now simulation files. Okay, so in case of simulation, directly diode bridge rectifier is it? So R load you are given. So what kinds of observation table, similar type of observation table you can do it. Okay, by changing the R value. Okay, for what type of changes are there. Basically, you can see that utilization factors. Okay, utilization factors you can also incorporate over here, but for your study. Okay, and the efficiency also been increased. Okay, so the parameters are already given, input, transient configurations, what are the parameters, everything is given from that waveform. Okay, now waveforms are there. From the waveforms, that input voltage, okay, load voltage, then load current for that full bridge diode rectifier, that is very simple. Now you are using RL load. Okay, RL load, and their parameters values are already given. Okay, and your waveforms also be there. Okay, for RL load, then RLE load. Okay, now you can change the large inductor value, so you can change it that value. Okay, so like your previous study. Okay, nothing more, only circuit is different. Okay, so by this way, some of the my sample studies I have given. Okay, so you can follow this one and modify your report as per your as per our requirement. Okay, so that observation table is very important. That's why. So waveforms are given. Now you can full wave. We are going for that angle is only 60 degree given here, but you can change it any of the angle you can take it, and that observation table you can change the angle value. Okay, 0, 30, 60. Okay, then 90, 120 degree, 150 degree, 180 degree. How much changes are there? You can check it from your circuit. Okay, now you know 60 degrees given. How it will be look like that. Okay. Now 150 degree, two samples are given. Okay, you can see that I am talking about this one. Okay, alpha value directly 150 means 150 volt you are giving the alpha, means it is 150 degree. That is I am asking for you. Okay, directly you can give it to T1, T2. Okay, both the configurations are there. This is for R load. Now we can go for RL load, RLE load. Okay, small inductance value. Okay, now it is your RL load. Okay, RL load it is given. Okay, now can you change the inductor value? That RL load. Now angle has changed up to 150 degree. Now large inductance value that 60 degree. Okay. Okay, waveforms are there. RL load with freewheeling diode. Okay, now we are increasing that firing angle with that RL load with freewheeling diode 150 degree. How the waveforms are there. The observation table you need to add in observation table. It's not given here. Okay, small inductance value. Then changing the waveform. How is it? How look like that? Okay. This is for RLE load. So you know that it's a shifting. Okay. So that it is starting from 0 to around 40, nearer to 48, 40, more than 45. Okay. So that is your back EMF. Okay. That E value. This is E value. Okay. You know that the current is in discontinuous mode of operations. Okay. That's why current value is 0. Okay. Changing of the firing angle, the current may be continuous to discontinuous mode. That can be observed in your observation table by changing the firing angle. Okay. Large inductance value. Okay, you can see the critical conditions. Okay. Current is not exactly 0, it is in critical conditions. Okay. Current is in critical conditions. You know, nearer to 0, but not exactly 0. Okay, by the variation of the firing angle. Firing angle is how much? For this study, you can see the firing angle is 60 degree. Okay. If you make it more, then what can be changes? What kinds of changes is there that you can see? Now firing angle is 150 degree. Okay. This is 150 degree firing angle. Okay. Now how it is changing? You can see the waveform. Sample are given, but in observation table, you can give the all of them. You can see more than firing angle, that current, most of the portion of current is 0. And that is very less current. Okay. That observation table one basic sample is given for your understanding. Measured output voltage. Okay. Calculated output voltage and percentage of error. Okay. How much percentage of error is there? Or not, this column is sufficient. I am giving some idea. Okay, you can incorporate efficiency portions, you can also add. So you can tally with your half wave converter. Okay, half wave uncontrolled and half wave control. So you can understand that which efficiency is more. So in last class, I am asking, not your section, in another section, I'm asking why the efficiency is less. Okay, they are not properly giving me the answer, but as today's I give that very good point. Okay, so you can tally with your results how the efficiency are varying, increase, decrease, like that. Here you know that voltage is back EMF is 40 volt. So you can see that is coming around the 40 from the waveform. Okay, here you can see it is coming around the 40. Okay, 40 here. Then conclusions. Okay, so some of the samples are given over here, so you can modify it as per your requirement. Okay, so I hope you are able to understand what you need to do. Is there any confusion? Any confusion? How would I know? Hello.
Yes, sir.
Okay, all of you getting the point? Angshuman?
Yes.
Okay, good. So I have already shared that file. I hope you have received it. Okay, so update. You can for your reference. I have already shared it. Okay, you please update your. You can complete your report and that pending portions. You please update it. Okay, I hope Mohesh will share me the link of your first experiment number 1 as soon as possible. Then I'm expecting the next link for the experiment number 2. Bikash, am I audible?
Yes, sir. Yes, sir.
Okay, so today now MCQ you can MCQ test you can give in to them. After that the Viva will be there. Okay.